0 to 8.
0 to 8. Why is it 0 to 8? You need a calculator. Why is it 0 to 8?
Because 0 is your smallest
You
point.
can pull that chair over here if you want to, or sit
Kind
back,
of sit
whatever,
back
whatever
on.
makes you happy, yeah.
0 is your smallest point.
Good. I get all kinds of wrong answers. The most common wrong answer I get on a problem like this is from 0 to 2. Why did I say 2? I know y'all probably
They
were,
took the cube percent.
yeah, they used, instead of the y value, they used the x value. Because they're so used to doing xy stuff, so they did, they're like, oh, if it's 8, then your x value was 2. So don't fall into that trap also if you need to flip flop it. Okay, there you go. Pretty straightforward. Pi, a derivative from 0 to 8. How would you tackle this?
2/3 y to 2/3.
I would rewrite this as y to the 2/3 and then go all polynomial on it.
Ooh. So,
Okay, antiderivative of y to the 2/3.
3/5 y to the 5/3.
Add 1, we're gonna get y to the 5/3, and multiply by the reciprocal, get 3/5. Evaluated from 0 to 8. This 3/5 pi is just a constant, so 3 pi over 5. Okay, let's plug in 8. Cube root of 8 is 2, 2 to the 5th is 32. Y'all do know how to work with fractional powers like that? Awesome. Click in 0, you get 0. So 3 pi over 5 times 32 is going to be 96 pi over 5, whatever that is. Something big. Something in the 65, 70 range. Something like that.
It's a lot.
Yeah, it's big. But it kind of makes sense. This is a relatively big area, and we are spinning that solid chunk around there, so it makes sense that it's that big. All right, there's a y problem. So changing things in terms of y instead of using the x values. It's the exact same setup, just don't get your brain messed up trying to use x things. Y'all did a good job converting this. You did a great job of using the 0 and 8 instead of the 0 to 2. There you go. Which is why I'm reluctant to write f of x. Might be f of y, however you want to rewrite this, okay? Just be careful. Notice that any of these x's could get turned into y's at a moment's notice. All right, does that feel pretty good?
Yes.
Excellent, good. Okay, where to next? I'm sorry, may I? Everybody good? All right. I'm gonna give you one to try on your own, or with each other, okay, and then I'm gonna sit back and judge you.
The judgment begins.
Okay, let's see how fun we wanna make this one. Okay. Sometimes they will do this to you. When they say first quadrant, which two boundaries are they giving you?
Y equals 0 and x equals 0.
Good, x and y equals 0, and not only that, because that technically cuts into 4 pieces, but they're telling you up here in this zone, okay? Because there may be other places where the zone overlaps or is contained, but they're telling you, okay, first quadrant, all right, other stuff. Below, let's do y equals x, and below, I'm running out of space here. Y equals minus x clear.
Okay.
And let's rotate that bad boy around the x-axis. Okay, this is a good free response worthy question. Okay, because it's got a little something on it. A little stank, if you will. Okay. I do not know which of these is the batteryless one.
So we want to draw.
That one's good. That one's that one's not good. Okay, so here you go. You have calculators if you want them. You also have calculators if you don't want them. I'm gonna sit back for a while and just watch and laugh.
Was that very nice?
Nope. Pencil?
I think I had one.
There you go.
Oh, yeah. Okay.
That works. Is that good? Anybody wanna pass forward to this?
Are you sure you don't want to pause?
Or pause through it, if you're gonna do that. You don't like this one? You don't like it?
I don't like it. You have to do it anyway?
You do.
Okay, I'm trying to draw a picture. It's not working.
Sorry. By the way, when they give you a calculator, when it's a calculator question, your points really come from setup and answer. So make sure you show what you would have typed into the calculator and then your answer, and that's good enough, okay? So I'm not really trying to make you sit here and do pages and pages of work.
So is this calculator question?
Yeah.
Oh,
Yeah.
Absolutely.
Alright, so there's section.
Everybody have one? Everybody got a calculator? Are you gonna use yours, Brandon, or are you just gonna? I'll let mine put it in.
Oh, what is this? Window.
And when y'all think you collectively, once you get something, check with everybody around you to see if you got something you think is right. that kind of the feel everybody got? With the description they gave us, so it was, notice how they could have, if they had not put a restriction on this one, if they had not said anything about first quadrant, then we would technically be talking about this wedge right here where they met. That'd be the only place that they were trapped in between. Issue with that is that the radius is changing a lot more than what my formula's giving me credit for, so I need some other, and, oh, this would be horrible, if we went around the x-axis, you'd have part of it kind of overlapping on itself,
Which means.
so you would need to know how much was overlapping so you can take it out. That's not a question they would ever ask you. I could, however, take this area and spin it around like a line up here to create some other cool shape, which we'll do, today and tomorrow.
Wouldn't it just be the same thing if you just cut the bottom part off, because it still would be overlapping, so it wouldn't matter.
No, because if you just cut the bottom part off, like this,
Yeah, just cut that off.
then there'd be a little sliver right here that would have been spawned that didn't overlap, that you would not have been counting.
Well,
Yeah, ooh. They wouldn't ask you that. So what kind of issues did y'all run into? I'm assuming y'all.
the intersection didn't work out unless you use a calculator.
Right, good, so here's a calculator, and I did this one specifically because of the way they worded it on the AP. The first thing you needed to know was
Or the intersection.
where they intersected, because this is technically two, okay? Two easy ones, it is, okay, we can do this much, the volume is gonna be the basically triangle wedge from 0 to wherever that point is, spin that. And the second one is gonna be from wherever that point was to 2, I think, is that where the quadratic hits, is it 2?
Yeah, it's at 2.
Okay, so this is 0, this is at 2, so the question then is, what is that specific cutoff point? So, we're gonna have integral 1 going from 0 to whatever that cutoff point is of the line, so pi r squared. Okay, so I need to know this. The second piece is gonna be pi going from unknown thing to 2, so that's where that hits the axis, of 4 minus x squared squared. So, what is that point? Did you happen to find it on the calculator? Yes, all right. Here's what I would suggest, for those of you that are still conscious, here's what I would suggest you do on the AP, because this will happen on the AP, I think it actually happened on the questions I gave you. All right, so here's what I'm doing, I'm going into y equals, and I'm graphing these to see where they meet. So number 1 is y equals x, number 2 is 4 minus x squared. Okay?
Trains.
6.
Trains, like 5.
Okay, lovely. So I'm gonna do second, calculate, which is over there by trace, intersect, and I need to make sure I'm kinda near the point I want, or it might give me the other point. And it tells me 1.56155528.
Yeah.
Okay, here's what you can do. Instead of writing that whole number out, by the way, do not round this, okay? Do not round this. Here's what I would do. Over to the side, or on the top, or somewhere, because you might be using this number a lot, make up a letter. Give me something that we're gonna let that number be. Like
Q.
Q, all right, so over the side, I'm gonna say Q is equal to 1.56155528. And now, because okay, here's one, they might have asked me just for the area. Question A, area. Question 2, if I spin it around the x-axis, what's the volume? Fine, or B. Question C, if this is the base of a solid and I want to build something out of it. So in every single one of those, you'd be using that number. So now that I've defined it somewhere, I can come over here and say I'm going to go from 0 to Q and from Q to 2. Very good trick, and I might even store that number over here on my home screen. I'm going to store 1.5615528, store alpha Q. Okay, so every time I hit Q on my calculator, it's just going to bring up that number.
Did you know there's a matrix button? Matrix button?
Yeah, I do know there's a matrix button.
I just saw that, I'm like, what's a hot?
It's not the kind of matrix that you wish it was, but it's still the matrix for it.
Brackets of A is error, so.
And if this is calculator, feel free to knock these out if you want to, but if it's a calculator question, I'm just gonna type all that garbage into my calculator and see what I get. You look like you're fading fast on me, yeah. Stay with me, girl, stay with me.
I'm staying.
It's about to get
I'm
awesome.
staying. I'm watching.
Okay, so let's see here, I'm going to do, type it all in. So, pi, math 9, from 0 to alpha cubed of x squared dx plus pi, math 9, from alpha cubed to 2 of parentheses 4 minus x squared close parentheses squared dx. Okay. I tried to call it out, especially for the video people, tried to call it out as I was typing it in so you know how to do it. The answer I get is 5.17766825, yada, yada, yada. So I would say at some point practice that to make sure you can plug it in. But I got 5.178. Okay? 177682539. Blah, blah, blah. Very handy trick. I would say almost all, in the last 15 years, I only remember 1 or 2 of the area questions ever being on non-calculator. These are definitely calculator type questions. Probably question number 1 or question number 2. Almost always number 1 for you guys. And they will probably give you something with a screwed up intersection point, so once you find it, get it. Now, here's another thing they might get you with. If I wanted to spin this thing around the y-axis, like maybe this chunk right here around the y-axis, I would not be using the x value, I would have been using the y value. So it might have been nice to say, if q is the,
It's the same thing.
No, that's the x value. Oh yeah, for this one, yes. For this one, because of this, it would be the same, yeah. In other examples, it might not be, yes. Very good.
This one might equal that.
This one you're good, so you get lucky. All right, everybody feel decent about that? We good? All right, so there's disk method. Disk
I get to do a washer.
We ready to move into washer? And I'm not gonna do all of washer today, just a little teaser of washer,
Ooh.
okay?
I was very close at home if you want me to bring it to
Funny, funny,
the washer humor.
funny.
Washer.
Okie dokie, let's take something like, well, let's keep it simple again to get started. We'll go back to a classic. So I'm paraphrasing here, but you get the idea. So you have, there's the zone, and then we're rotating this about the x-axis. Yes? Thank you, man. Good, thank you. Have a wonderful lunch. Okay, first thing I might try and do on this one is to graph it just to see what's going on. I didn't make it too rough to start with. So we have good old square root of x, graph that one a couple of times.
Go square root of x.
Okay, good old square root of x. And then 1/2 x is gonna be a little bit lazier line, something like that.
Ooh.
Okay, so this is the zone that we're talking about spinning.
It's a little pretty.
And we're gonna spin that around the x-axis in this case. All right. Here's the reason that it's called washer. If you think about what the shape is going to look like
I don't even know how I'm gonna do it.
when I spin this. So we'll have this on the bottom, like that. The line will kind of come through like that. Close enough. there?
Are you
Okay.
gonna minus the?
Very good. When I slice it, let's say I slice it right here. When I spin that, I'll do a good 3D here. So that might be what one particular slice is going to look like. So we've got all this.
Oh,
I don't like how that looks.
Huh?
I don't like
great.
Sorry.
it. You're not sorry.
I tried to.
So I'll find your section.
Do you see why it's called the washer method?
Cause it makes a washer.
Because it makes a washer in the construction sense, not the cleaning clothes sense, okay? So those of you familiar with what a washer actually looks like from construction. Sometimes
washer
called the
door.
ring method, but ring method is kind of modern and real math people use the washer method. However, you can, well, the shape itself, this is kind of a cool word, good vocabulary word. The shape itself, like a bullseye, you have a circle with a circle cut out of the center, is called an annulus. Not that has anything to do with the AP test or they care about that, but if you're interested, the geometric
So
shape
I
of
can't
a
just put an
ring.
arrow, be like,
Here's an annulus, you can, but they'll be like, all right,
no.
Yeah.
what's the area of the, what's that? So you can sound snitty with your
So
friends,
what's the-
like, ooh, look at this
So,
ring I
the area of
got.
an annulus
Like,
is
check
just
out
this.
that annulus. Yeah.
And the annulus, the area.
I
of
showed
the
them the
annulus is just a
picture
circle.
of the shirts.
Minus-
They told me if I wear it, they'd punch me in the face.
Who?
A few people when I showed them the shirts.
Who?
Jeannie was upset with me with that
I don't
shirt.
care, so.
Which one?
The one in your class.
I know which jeans, which shirt, was she angry about?
Oh,
Careful, wrong video, which shirt was it?
it was, the I ate
Yeah.
pie one.
Really?
That's not
I ate
bad.
some pie.
She didn't get it, I had to explain it.
Well, the summation's the only one that she
Yeah.
probably wouldn't understand.
No, she didn't know the other one.
I
I don't know, she really,
Eight, she should get it. Pie,
She
she should
should've.
get it.
I think she
Square
got
root
the,
of -1 is I, she should know that.
she should know, but I don't think it was coming into her head.
Anywho.
I
I showed her the other one too, I just can't say that on camera.
The integral of e to the x one.
Yeah.
Yeah. Okay, so volume for us. Think about how we would set this one up. Talk about it, not necessarily the equation itself, but talk about how we would find the volume of this one.
you just take, you do your,
I feel like pie.
you find where they intersect, you wanna know where that point is.
Right.
Is it like
And then you
circumference,
just
could
get-
it be circumference?
No,
Is it
that's
an
hard,
area?
that's a hard topic. Surface area is a hard topic.
Oh.
What about
okay,
the
so
surface
it's not
area
that.
of that shape at the
I
end?
just
and then
said
the
that.
inner surface-
Think
oh,
about it,
that's
it's the
so-
same formula, you can figure out the surface area. Surface area is honestly not even a BC topic, though it's not that
Honestly.
bad. You would technically take the surface area of the outside and then take the surface area of the inside, so that's your surface area.
What you're gonna do is find your intersect point, so you know where
Okay,
your
so-
end point is.
Good, I think I picked a nice one, I think it's at 4.2.
Yeah.
I picked one that worked nicely for both of them, figure out where they met, it is at 4.2. Okay, so that helps with our interval, starting and stopping.
Then you're gonna, it's pretty much your top, well, yeah, in this case, your top function, but your outside function minus your inside function.
That's exactly the way you need to think about it. So washer method is really just two discs. You do the full volume of the bullet we did before, and then you subtract out the volume of the cone that's gonna be on the inside, okay? That's all the washer method is. Let me pause here then to write for our rotational volume with washer, okay? We write it this way usually, pi from A to B. Outside radius squared, now I just use our outside, I'll use a big R for that,
And then-
minus inside radius
which is
squared.
all.
Okay, so it's basically two disk methods. The absolute most common mistake, again, that you will all make at some point, is to subtract first and then square. It is two separate discs, square first, then subtract. So for this one,
Two separate rules.
you could write it as two separate integrals if you think you're gonna mess yourself up, yeah. The only reason I would say, sometimes that's nice. However, if you were to square both of these and they somehow combine together to make a cleaner integral, then, it might help with arithmetic, but to save yourself the heartache, you might wanna split it in two. This one does go from 0 to 4, is that what it said? 0 to 4, okay. Outside radius, here's how you should think of outside radius. I always start drawing from the line I'm rotating around. And the easy ones we've done so far have been x-axis and y-axis. We're gonna jump that up tomorrow. So from the radius, from the center, go to the outside function, okay? The farthest point that you can get to, that is your outside radius. And then from the center to the closest one is your inside radius, big R versus little r. Messed up the word, annulus, it's okay. Alright, there we go. So our outside radius in this example is going to be the square root. Big R squared minus little r